to section 5.7. Much of today is going to be review of inverse trig functions, review of their derivatives, and what's new is integrals involving inverse trig functions. So way back in the beginning of the semester, I had you memorize these, which are the restricted domains for sine inverse, cosine inverse, and tangent inverse. So let's do some problems involving that chart. Find cosine inverse of -1/2. So take cosine of both sides. Cosine of y is -1/2, and y has to be an angle between 0 and pi. This is pi, and this is 0. Okay, well that narrows it down to just one angle. Y equals 2 pi over 3. There's a picture right there. Cosine of that angle is -1/2. All right, next one. Again, take sine of both sides. Sine of y is -√3 over 2, and y has to be an angle in that restricted interval from -pi over 2 to pi over 2. So that would be this angle here, which is the angle -pi over 3. And finally, the last example, here we want tangent inverse of tangent of pi, and you might think, well, the answer is going to be pi because tangent inverse undoes what tangent does, but it's not quite that simple. Let's simplify the inside first. Y is tangent inverse of tangent of pi is 0, so what we want is tangent inverse of 0. So that means tangent of y is 0, and y is an angle between -pi over 2 and pi over 2, not including those two endpoints. That's why I'm using a dotted line. All right, well, that's the angle 0. Okay, derivatives of inverse trig functions. You memorize these back in, I believe it was section 3.7. Recall that the second column is just the negatives of the first column. So really, it's just one column to memorize. And let's just go through and do 3 quick examples, and then we'll get on to the new stuff. So we want sine inverse of 2 minus x. So I'm going to use this formula right here, and I'm going to let u equal 2 minus x. You don't have to write that down. I'm just doing that so you know what u is in that formula. Y prime is, we want u prime on top, that's -1. And in the denominator, we want 1 minus u squared. And we'll just leave it like that. Okay, next one, tangent inverse. So I'm going to use this formula, u prime over 1 plus u squared. And here my u is 4x cubed. So y prime is the derivative of 4x cubed, which is 12x squared, over 1 plus 4x cubed quantity squared. All right, and we want to simplify that. That's 12x squared over 1 plus, need to distribute the square, so 4 squared is 16, and x cubed squared, multiply the exponents, is x to the 6. All right, finally another tangent inverse, but now our u of x is e to the 2x. So on top, I want 2 e to the 2x, that's the derivative of e to the 2x, and in the denominator, I want 1 plus e to the 2x all squared. Just review of exponents here. E to the 2x squared, multiply the exponents. That's 4x is our new exponent. So 2e to the 2x over 1 plus e to the 4x. I guess I'm circling my answers. Okay, integrals. Here are the 3 the 3 formulas that you have to memorize that involve the inverse trig functions. Notice that sine inverse is the only one of the 3 without a 1 over k out front. The way I remember that is in Spanish, sin means without, something like that. And so think sine sin without the 1 over k. All right, first one, straight up tangent inverse. So this is straight up this formula right here, with k equal to 5. So this is going to be 1/5 tangent inverse of x over 5 between -5 and 5 root 3. That's 1/5. Pull the constant out. Tangent inverse of, if I put in the upper limit, I get √3. And if I put in the lower limit, -5, I get tangent inverse of -1. Okay, and this is why we did the review of just finding inverse trig functions in the beginning, because this comes down to finding the values of inverse trig functions. This is 1/5. Tangent inverse of √3 is that angle between -π/2 and π/2, whose tangent is √3. That's π/3. And tangent inverse of -1 is down here. It's -π/4. So that's π/3 plus π/4. And so if we simplify that, we get 7π/60. Get a common denominator and then multiply by 1/5. Okay, next one. This looks closest to the first formula, the formula for sine inverse. It's something squared minus a variable squared. However, we've got that 4 there, which is complicating things. So what I'm going to do is a u sub to make it look exactly like that formula above. So I'm going to let u equal 2y, and du is 2 dy. I don't have 2 dy, I have 1 dy, so 1/2 du is dy. And so this becomes 1/2 the integral of 1 over the square root of 36 minus u squared du. All right, I picked 2y for u because I noticed that 4y squared was exactly 2y quantity squared. Now, this looks exactly like the formula in the chart with k equal to 6. And so this is remember the formula for sine inverse, you don't bring a 1/6 out. So this will just be 1/2 sine inverse of u over 6 plus c, because it's an indefinite integral. And then finally back substitute 1/2 sine inverse u is 2y over 6. Well, I guess that wasn't finally, because I can clean that up just a little bit. 1/2 sine inverse of y over 3 plus c. Okay, next one, you might want to pause it and try it yourself. All right, hopefully you did that. This looks closest to the tangent inverse formula, but again, we have 4x squared, not just x squared. So again, I'm going to let u equal 2x, du is 2 dx. I have 4 dx, so 2 du is 4 dx. So this is the integral of 2, put that out front, and then 1 over 1 plus u squared, because 4x squared is 2x all squared, du. And since this is a definite integral, we're going to change our limits. When x is 0, u is 0, and when x is 1/2, u is 1. So those are the new limits. And this is 2 tangent inverse of u, because our k is 1 in that formula above, k is 1, between 0 and 1. I'm not going back to x's. I changed my limits, so I'm going to stick with u's. This is 2 tangent inverse of 1 minus 2 tangent inverse of 0. Okay, we saw on the first page, tangent inverse of 0 is 0. Tangent inverse of 1 is π/4. So this is 2 times π/4, which is π/2. And that is the end of this section.